Yes, non-rated pressure transmitters and other electronics can be placed in a Class 1 Division 1 enclosure by using an explosion-proof junction box with tubing running into it for the pressure transmitters. Explosion-proof junction boxes are designed to house and protect electrical equipment in hazardous areas where flammable vapors or gases may be present. These boxes are built to withstand internal explosions and prevent the ignition of surrounding flammable atmospheres. To install non-rated pressure transmitters and other electronics in an explosion-proof junction box and run tubing into the box, consider the following steps. Firstly, select a suitable junction box. Choose an explosion-proof junction box that is large enough to accommodate the pressure transmitters and other electronics. Ensure the box is rated for the specific Class 1 Division 1 environment. Secondly, install the junction box. Mount the explosion-proof junction box in the desired location. Ensure that it is securely fastened and meets the requirements of the electrical code. Thirdly, run tubing into the box. Use appropriate tubing such as stainless steel or flexible conduit to connect the pressure transmitters to the junction box. Seal the entry points of the tubing into the box using explosion-proof fittings or glands. Fourthly, install the pressure transmitters and other electronics. Place the non-rated pressure transmitters and other electronics inside the junction box. Ensure that they are securely mounted and protected from physical damage. Fifthly, seal the junction box. Close and seal the junction box cover using the provided fasteners or clamps. Ensure the cover is properly tightened to maintain the explosion-proof integrity of the box. When working in a Class 1 Division 1 environment, it is essential to follow all safety protocols and electrical codes. This includes proper grounding, bonding, and the use of appropriate tools and equipment. Always consult with a qualified electrician or engineer for any electrical work or installation. Class 1 locations are those in which flammable gases or vapors are or may be present in the air in quantity sufficient to produce explosive or ignitable mixtures. Division 1 is a condition where the hazard is likely to exist under normal operating conditions. Explosion-proof enclosures are designed to contain an explosion that occurs within the enclosure and prevent it from propagating to the outside atmosphere. This is achieved through robust construction, tight-fitting covers, and flame paths that cool the escaping gases below their ignition temperature. Junction boxes used in hazardous locations must be specifically certified for that purpose. These certifications, such as those from underwriters' laboratories, or UL, and other recognized testing laboratories, ensure that the equipment meets stringent safety standards. The selection of the correct junction box is critical. The box must be rated for the specific class and division of the hazardous location as well as the type of gas or vapor present. The size of the box must also be adequate to house all the equipment and wiring without overcrowding, which could lead to overheating or other problems. Proper installation is essential for maintaining the explosion-proof integrity of the system. The junction box must be securely mounted to a stable surface and all conduit connections must be properly sealed with explosion-proof fittings. These fittings create a flame path that prevents flames or hot gases from escaping the enclosure. The wiring inside the junction box must also be done in accordance with the electrical code. This includes using the correct wire size, insulation type, and terminal connections. All connections must be tight and secure to prevent arcing or sparking. Grounding is another critical aspect of the installation. The junction box and all equipment inside must be properly grounded to prevent the buildup of static electricity which could ignite a flammable atmosphere. The grounding conductor must be sized according to the electrical code and connected to a reliable grounding system. The tubing used to connect the pressure transmitters to the junction box must also be suitable for use in hazardous locations. Stainless steel tubing is often used because it is corrosion resistant and can withstand high pressures. Flexible conduit can also be used, but it must be approved for use in Class 1 Division 1 locations. The entry points of the tubing into the junction box must be sealed with explosion-proof fittings or glands. These fittings prevent flammable gases or vapors from entering the enclosure through the tubing. The pressure transmitters themselves do not need to be explosion-proof if they are housed within an explosion-proof junction box. However, they must be suitable for the process conditions such as the pressure and temperature of the fluid being measured. The transmitters should also be protected from physical damage and vibration. The junction box cover must be properly sealed to maintain the explosion-proof integrity of the enclosure. The cover should be tightened using the provided fasteners or clamps to ensure a tight seal. The cover gasket should also be inspected regularly and replaced if it is damaged or worn. Regular inspections and maintenance are essential for ensuring the continued safety of the installation. The junction box, fittings, and wiring should be inspected regularly for signs of damage or corrosion. Any damaged or worn component should be replaced immediately. The grounding system should also be tested periodically to ensure that it is still effective. Working in a Class 1 Division 1 environment requires specialized training and knowledge. It is important to consult with a qualified electrician or engineer before performing any electrical work in these locations. They can provide guidance on the proper selection, installation, and maintenance of explosion-proof equipment. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in hazardous locations. It is important to be familiar with the applicable NEC articles and standards before performing any work in these areas. Article 500 contains the general requirements for hazardous locations. Articles 501 through 506 provide specific requirements for different classes, divisions, and zones of hazardous locations. In addition to the NEC, there may be other applicable codes and standards, such as those from the Occupational Safety and Health Administration, or OSHA, and other regulatory agencies. It is important to be aware of and comply with all applicable requirements. Explosion-proof equipment is designed to contain an internal explosion, but it is not designed to withstand external explosions. Therefore, it is important to take steps to prevent explosions from occurring in the first place. This includes controlling sources of ignition, such as open flames, sparks, and hot surfaces. It also includes preventing the release of flammable gases or vapors into the atmosphere. Ventilation is an important means of controlling the concentration of flammable gases or vapors in the air. Proper ventilation can help to dilute the concentration of these substances below their lower explosive limit, or LEL. The LEL is the minimum concentration of a flammable gas or vapor in air that will support combustion. Gas detectors can be used to monitor the concentration of flammable gases or vapors in the air. These detectors can be set to alarm if the concentration exceeds a certain level, providing an early warning of a potential hazard. Emergency shutdown systems can be used to automatically shut down equipment and processes in the event of a hazardous condition. These systems can be triggered by gas detectors, fire detectors, or other sensors. Hot work permits are required for any work that could create a source of ignition, such as welding, cutting, or grinding. These permits ensure that proper precautions are taken to prevent fires or explosions. Housekeeping is also important for preventing fires and explosions. Flammable material should be stored in approved containers and disposed of properly. Accumulations of dust or debris should be cleaned up regularly. Static electricity can be a source of ignition in hazardous locations. Steps should be taken to prevent the buildup of static electricity, such as grounding equipment and using static dissipative materials. Lightning protection systems can protect buildings and equipment from lightning strikes, which can be a source of ignition. These systems should be installed and maintained in accordance with the applicable codes and standards. Training is essential for all personnel who work in hazardous locations. They should be trained on the hazards of the environment, the proper use of explosion-proof equipment, and the emergency procedures to follow in the event of a fire or explosion. Regular drills and exercises can help to ensure that personnel are prepared to respond effectively to emergencies. A management of change program should be in place to ensure that any changes to equipment, processes, or procedures are properly evaluated for their potential impact on safety. This program should include a formal review process and require approval from qualified personnel before any changes are implemented. Audits and inspections should be conducted regularly to verify that the safety program is being effectively implemented. These audits and inspections should be performed by qualified personnel and should include a review of documentation, equipment, and procedures. The findings of the audits and inspections should be documented and used to identify areas for improvement. A continuous improvement process should be in place to ensure that the safety program is constantly being evaluated and improved. This process should include feedback from personnel, analysis of incidents and near misses, and the incorporation of new technologies and best practices. The use of explosion-proof junction boxes and other safety measures can significantly reduce the risk of fires and explosions in hazardous locations. By following the proper procedures and adhering to the applicable codes and standards, it is possible to create a safe working environment for personnel and protect property from damage. Remember that safety is always the top priority when working in hazardous locations. Never take shortcuts or compromise on safety procedures. If you are unsure about anything, always ask for help from a qualified professional. Explosion-proof enclosures are typically made from robust materials such as cast iron, aluminum, or stainless steel. These materials are chosen for their ability to withstand high pressures and temperatures. The enclosures are designed with tight-fitting covers and flame paths that cool the escaping gases below their ignition temperature. The flame paths are typically long, narrow gaps that allow the gases to escape slowly and cool as they pass through the gap. The width of the gap is carefully controlled to ensure that the gases are cooled sufficiently to prevent ignition of the surrounding atmosphere. The covers of explosion-proof enclosures are typically secured with multiple bolts or clamps to ensure a tight seal. The bolts or clamps must be properly tightened to maintain the integrity of the enclosure. The enclosures are also typically equipped with gaskets to provide a seal between the cover and the body of the enclosure. The gaskets must be made from materials that are resistant to the chemicals and temperatures present in the hazardous location. Explosion-proof enclosures are tested to ensure that they can withstand an internal explosion without propagating it to the outside atmosphere. The testing typically involves igniting a flammable mixture inside the enclosure and measuring the pressure and temperature outside the enclosure. The enclosure must be able to contain the explosion without rupturing or allowing flames to escape. Explosion-proof enclosures are marked with information about their rating, including the class, division, and group of the hazardous location for which they are approved. The marking also typically includes the manufacturer's name, model number, and serial number. It is important to select an explosion-proof enclosure that is properly rated for the specific hazardous location in which it will be used. Using an improperly rated enclosure could result in a fire or explosion. Explosion-proof enclosures must be installed in accordance with the manufacturer's instructions and the applicable codes and standards. The installation typically involves mounting the enclosure to a stable surface and connecting the wiring and conduit in a proper manner. The wiring and conduit must also be approved for use in hazardous locations. Explosion-proof enclosures must be maintained in good condition to ensure their continued safety. The enclosures should be inspected regularly for signs of damage or corrosion. Any damaged or corroded components should be replaced immediately. The covers of explosion-proof enclosures should be kept clean and free of debris. The gaskets should be inspected regularly and replaced if they are damaged or worn. The bolts or clamps that secure the cover should be tightened properly. Explosion-proof enclosures should not be modified or altered in any way. Any modifications or alterations could compromise the integrity of the enclosure and result in a fire or explosion. If an explosion occurs inside an explosion-proof enclosure, the enclosure should be inspected by a qualified professional before it is returned to surface. The inspection should verify that the enclosure is still in good condition and that it is properly rated for the hazardous location. The use of explosion-proof enclosures is just one part of a comprehensive safety program for hazardous locations. The program should also include measures to prevent the release of flammable gases or vapors into the atmosphere, control sources of ignition, and train personnel on the hazards of the environment. By implementing a comprehensive safety program, it is possible to create a safe working environment for personnel and protect property from damage in hazardous locations. Consider a scenario where a chemical plant uses pressure transmitters to monitor the flow of flammable liquids. The transmitters are located in a Class 1 Division 1 area where there is a high risk of explosion. To protect the transmitters and prevent an explosion, the plant installs them in explosion-proof junction boxes. The junction boxes are made of cast iron and have tight-fitting covers with flame paths. The tubing used to connect the transmitters to the junction boxes is made of stainless steel and is sealed with explosion-proof fittings. The wiring inside the junction boxes is done in accordance with the electrical code and the boxes are properly grounded. The plant also has a comprehensive safety program in place that includes measures to prevent the release of flammable liquids, control sources of ignition, and train personnel on the hazards of the environment. The safety program is regularly audited and inspected to ensure that it is being effectively implemented. Thanks to these measures, the chemical plant is able to operate safely and prevent explosions, protecting its personnel and property. The characteristics of flammable substances play a crucial role in determining the appropriate safety measures for a Class 1 Division 1 location. Firstly, the flash point is a critical factor. This is the lowest temperature at which a liquid gives off vapor sufficient to form an ignitable mixture with air near the surface of the liquid. Substances with low flash points are more easily ignited and require more stringent safety precautions. Secondly, the auto-ignition temperature is another important parameter. This is the temperature at which a substance will spontaneously ignite in air without an external ignition source. If the operating temperature in the Class 1 Division 1 area approaches the auto-ignition temperature of a flammable substance, special measures must be taken to prevent ignition. Thirdly, the explosive limits, both lower explosive limit (LEL) and upper explosive limit (UL) define the range of concentrations of a flammable substance in air that will support combustion. If the concentration of a flammable substance is below the LEL, there is not enough fuel to support combustion. If the concentration is above the UL, there is too much fuel and not enough oxygen to support combustion. Safety measures must be designed to keep the concentration of flammable substances outside of the explosive limit. Fourthly, the vapor density of a flammable substance is the weight of its vapor compared to the weight of an equal volume of air. If the vapor density is greater than 1, the vapor is heavier than air and will tend to accumulate in low-lying areas. If the vapor density is less than 1, the vapor is lighter than air and will tend to rise. This information is important for determining the appropriate ventilation strategies. Fifthly, the chemical reactivity of a flammable substance is also important. Some substances are more reactive than others and may react violently with air, water, or other substances. Safety measures must be designed to prevent unintended reactions. Grounding and bonding are essential safety practices in Class 1 Division 1 locations to prevent the buildup of static electricity, which can be a source of ignition. Grounding involves connecting a conductive object to the earth, providing a path for static electricity to dissipate. Bonding involves connecting two or more conductive objects together to equalize their electrical potential. The NEC provides detailed requirements for grounding and bonding in hazardous locations. Section 501.16 specifies the grounding requirements for Class 1 Division 1 locations. All metal equipment, including junction boxes, conduit, and enclosures, must be grounded. The grounding conductor must be sized in accordance with NEC Table 250. 122. Bonding is also required to ensure that all metal objects are at the same electrical potential. This prevents sparks from occurring between objects if one becomes charged with static electricity. Bonding conductors must be sized in accordance with NEC Table 250. 102. In addition to grounding and bonding, other measures can be taken to prevent static electricity buildup. These include using static dissipative materials, controlling humidity, and avoiding activities that generate static electricity, such as rubbing or brushing non-conductive materials. Proper grounding and bonding are critical for preventing static electricity ignition in Class 1 Division 1 locations. Regular inspections and maintenance are essential to ensure that the grounding and bonding systems are functioning properly.